Welcome back to this series of talks with Ken Figueiredo and Andreas to introduce some of the basic concepts involved in developing IoT systems.
Hello, Ken.
Hi, Andreas. So today you're going to introduce the access control function in 1M2M. Tell us, what is its purpose?
Let's go back to the streetlight example we have been using. Here's a simple case where we have streetlights in two neighboring districts, possibly under the management of two different agencies. Let's say that two streetlights are close to one another, so that one streetlight is switched on. We would like its neighbor, which belongs to a different district, to turn on as well. In this example, we have one device collaborating with another without human intervention.
So to use an old term, that looks like a good example of machine-to-machine communications.
Yes, that's a good reminder. The idea of access control policies is to allow this kind of interaction and to do it safely, so that one streetlight can accept commands from another, but not leave itself exposed to unauthorized third-party commands.
I see. So let's see how 1M2M makes that work.
In the Jupyter notebook I'm about to show you, I will use only two streetlights, which are AE1 and AE2.
Okay, so you're showing AE1 and AE2, and they talk to one another through the 1M2M service layer. How do we know who sent a request to our 1M2M IoT platform? Is this part of the request?
Yes, exactly. Every 1M2M request includes an identifier called originator. That allows the 1M2M CSE to perform matches between a request sender identity and the installed access control policies. In our case, AE1 has the originator C-streetlight AE1 and AE2 has the originator C-streetlight AE2.
Okay.
I'm going to explain the steps using this illustration, which you will see copied in the notebook. There are two major blocks. The one on the left is a notebook we are using to issue commands for the purposes of this exercise. That is to the left of the diagram. On the right-hand side, I am showing the resources that correspond to the operational system. In this case, there are two streetlights, A1 and A2. Each of them has their own originator ID, set C streetlight A1 and C streetlight A2, respectively. It is important for this scenario to note which request uses which originator ID.
Okay, so I see that you use these illustrations in the notebook, which is very helpful. What you're essentially showing here is the notebook AE simulating commands between the streetlights. Is that correct?
Yes, that is correct. The first action is to send a request to the CSE to create a content instance under the AE1 structure and with the originator C streetlight AE1.
Okay, so the content instance is for storing data related to an entity. Is that right?
Yes, and in our case, that could be a command to switch on the streetlight. In the next step, I will send a second request to simulate the case of AE1 wanting to create a content instance under AE2. Here, again, we are using the originator C streetlight AE1. This will fail because there are no access control privileges between AE1 and AE2. The default in 1M2M is to deny requests when no privileges are defined.
Okay, that makes sense. So that is where the idea of access control policies come from.
Yes, and here's how it works in 1M2M. Streetlight ACP2 is a mechanism we use to associate access control with identities. 1M2M also uses a coding system to define operational privileges, as you can see on the right.
I see. So setting the privilege code field to 2 would allow one AE to retrieve data from another AE.
Yes, you can also combine values. For example, setting the code field to 5 allows one AE to create and update another AE.
Okay, thanks for that clarification. Should we now shift to the notebook to see the full scenario?
Yes, let's do that. Okay, let's start with starting our CSE in the notebook. And now we switch to the access control notebook, where we start with our usual initialization. It already creates an initial resource tree, as with the last time we had with the groups. Go here and start. We create a content instance resource for each of the streetlights. We start with AE1. Which is perfectly fine because we use this originator, C streetlight AE1, and we are allowed to send a command or to create a content instance to the AE. Now we do the same using, again, our originator, C streetlight AE1, but now we are sending it to AE2. This should fail because we don't have privileges, and also the error message gives us a forbidden and that we don't have privileges for a create request.
Okay.
And as we can see in our resource tree, no content instance has been created under the streetlight AE2.
Okay.
Okay. Now, how can we do this here? How can we actually allow AE1 to create content instance here? So we are creating a so-called access control policy resource that contains all the information who is allowed and which operations are allowed for that originator. It's a bit more complicated, as you can imagine. The resource is a bit bigger, but here we are showing only the essentials. This time, because we have to do this as streetlight AE2, that can actually create this access control policy resource, and we're creating it under our AE. Let's do that. It has been created, and we can see it here in our resource tree. It's here under the streetlight AE2. And this contains information about that. Let's scroll up a bit again. That we have the C streetlight AE1 originator is allowed the access control operation 1, which is create. And we are also giving ourselves, of course, all the access control that we have had before. Now, what we have to do, we have the rules in place, the policies in place. Now what we need to do is to assign access control. In one M2M, access control can be really fine-grained. You can do it basically on a resource by resource basis so that you can actually give very fine-grained access to your resource tree and to your data. This is done by assigning the resource ID to an attribute called access control policy IDs. Let's do that. As you can see, now the container has a new attribute here, access control policy IDs, with the resource identifier of this access control policy resource.
Okay.
Now we are repeating that we are using our originator from AE1 and accessing or creating a content instance under the AE2 and giving a command to switch on the lights. And this time, the request goes through, it's allowed because we have the access control and the policies to do that. Here it is, here's our container.
Okay. So this is quite a powerful capability. What you're saying is any IoT device or resource can create a policy that it would allow it to interact with a different IoT resource.
Yes, you can do this on the device level. You can do it on the data point level, so that, for example, somebody is only allowed to read maybe the status of the streetlights, and somebody else is even allowed to manage those resources.
Okay, so a very powerful tool as organizations start looking at machine-to-machine communications and also data sharing.
Yes.
Okay, well, you've covered quite a lot. Thank you very much for that. As usual, viewers can access your notebook and experiment with these tools as and when they wish. So once again, thank you, Andreas, and I look forward to our next talk.
Thank you very much, Ken.